Hello learners, welcome to this course on practical machine learning using Google Colab. In this tutorial, I will be describing about a machine learning algorithm named K nearest neighbor classifier. So a classifier, it classifies the data points or it segregates the data points into different categories. So one such classifier is K nearest neighbor. So from the name itself, it suggests that we need to find the nearest data point or the nearest or closest or similar data point. So where this K stands for how many such data points we need to find or how many such closest data points we need to consider while assigning a label to a new data point. So K nearest neighbor algorithm, it classifies the unknown data points by finding the most common class among the K closest examples. So where each data point in the K closest data point, it casts a vote. Each data point, it says a particular class of label for the new data point. And depending upon the highest number of votes, a particular label is assigned to the new data point. So that is how this K nearest neighbor classifier works. So if I have some 100 data points in the training data set and a new data point comes in, then we try to find the similar or closest data point depending upon the K value. If my K value is 1, then I take the very closest data point. If my K value is 3, then I will try to take the 3 closest data point. If my K value is 5, I try to take 5 closest data point. So depending upon this result, for example, in case of a 5, K value to be 5, if 3 data points says it is class A and 2 data points says it is class B, then the majority voting is with class A. Then class A label will be assigned to the new data point. That is how this K nearest neighbor works. So in order to find the closest match or similar metric, we use either a Euclidean distance metric or Manhattan distance metric. So this Euclidean distance metric, it is also called as L2 distance metric. Manhattan distance metric is also called as city block or L1 distance metric. So here we try to find the distance between the two vectors. If the distance between the two vectors is small, which means the two data points are similar in nature. If the distance between the two vectors is large, then the two data points are dissimilar in nature. So let us compute this Euclidean distance metric and Manhattan distance metric using this equation, where in Euclidean distance metric, d of p comma q is equal to root of summation I minus 1 to n qi minus pi to the square. Whereas in case of a Manhattan distance metric, the distance is computed by summation of I minus 1 to n mod of qi minus pi, where this p and q are vectors. So let us try to see an example in case of a Euclidean distance metric. So let us take two vectors. So p equal to 1, 3, 5. So I just take a 3-dimension vector, which means I have 3 elements in p vector. Same way another 3-dimension vector in q. So 2, 4, 6. Where this first element is P0, second element is P1, third element is P2. Same way in Q vector, first element is Q0, Q1 and Q2. So let us compute the distance between the two vectors. So d of P comma Q equal to root of, first we take Q0 minus P0, which is 2 minus 1 square plus 4 minus 3 square plus 6 minus 5 square. So which is equivalent to root 3, which is equal to 1.732. Let us take another two vectors where I am going to keep the p vector as same, 1, 3, 5. I am just going to change the q vector. So q vector I am going to take 10, 20 and 30. So let us compute the distance between these two vectors, p comma q equal to root of, again do the similar procedure. So 10 minus 1 square plus 20 minus 3 square plus 30 minus 5 square. So which is equal to root of 9 square plus 17 square plus 25 square. So let us compute this. 9 square plus 17 square plus 25 square, so equal to 625. So 625 I am going to take root, which is equal to 25. So this is equal to 25. So if I see the distance between these two vectors, p vector which is 135, when I compare it with q vector 246, the distance value is about 1.732, whereas the same p vector when it is compared with q vector of 10, 20 and 30, the distance is 25, which means the higher value, if distance is high, which means the two vectors p and q are dissimilar in nature. Dissimilar. If the distance is small, which means p and q are similar in nature. By performing this procedure, we can compute whether the two vectors are similar or not, or whether the two vectors are closest to each other or not. That we can find. So once we identify the distance between the two vectors, and it is done for the entire data set, and then we try to vote depending upon the k value. So depending upon the k value, the label with the majority voting will be assigned to the new data point. Let us see this with an example. So let us take a data set of three types of flowers: sunflower, daisy and pansies. So three flowers we are going to take, and I am going to consider two features. One is size of the petal, another one is lightness of the petal. So here I take two feature vectors. So depending upon this feature vector, we do the training process. For example, here you see along x-axis I have the size of the petal. So here it indicates small size. As I go towards right, here I have a large size of the petal. Same way along y-axis, we have the lightness of the petal. So here I have a dark color, and when I go towards top, I have light or bright pixel values. So here I take a sunflower, pansies and daisy. So when we put these three classes, sunflower, pansies and daisy, depending upon this two features, it groups like this. So pansies as a dark color and also the size of the petal is small, so it comes here. Sunflower is a little bit brighter when compared to your pansies and it has a large size petals, so it comes under in this location. Daisy is the brightest of the three categories and its size of the petal lies between pansies and sunflower, so it comes here. So now we have used this data set for training our machine learning algorithm so that it has learned how a pansies look like, sunflower look like and daisy look like depending upon the two features, size of the petal and lightness of the petal. So now let us try to do the testing part. In the testing part, a new data point comes. So here I have taken a new data point. So this data point needs to be identified or it needs to find the closest match. So let us take an example, k equal to 1, which means I need to find the very first closest match or high closest match. So we need to compute the distance between this new data point and the already trained data points. So we compute the distance between these two images, these two, same way for all the images we find the distance matrix. We compute the distance matrix with the new data point and already available data points in the data set. So thereby I get multiple distance matrix. So in that I need to find the closest distance. So which is this image is very closest to your new data point. So we need to see the label of this data point, which is daisy, and we try to assign the daisy to the new data point too. So this is how the k nearest neighbor algorithm works. So let us consider another test example. If I take a k value to be 3, in case here I have a new data point here. Now I have taken the k value to be 3, so I need to take the top 3 closest matches. So here when I do the same distance metric computation of the new data point with all the other data point in the training data, so I try to take the top 3 closest match, in which one says it is daisy and another 2 says it is sunflower. So here I try to take the label with the majority voting. So the majority voting is coming for sunflower category. So this new data point will be assigned with sunflower label. So that is how a prediction is made by a k nearest neighbor algorithm. So here in k nearest neighbor we have certain parameters to be tuned, which is something like what should be my k value, whether I should keep a k value of 1, 3, 5, 7, which will give me the highest accuracy. So that needs to be tuned. Same way, what type of distance metric we need to consider, whether I need to use a Manhattan distance or Euclidean distance or chi-square distance. So which distance metric will give me the best performance? So like that we have certain parameters to be tuned. So such parameters are called as hyperparameters. So this hyperparameters needs to be tuned. So here when I say the k value as 1, 3, 5, 7, so I am not describing about k value to be 2, 4, 6, because if I take an even value of k, then I will have an option or probability that, for example, let us take, if I take a k value to be 2, then one data point says it is class A and another data point says it is class B. Then our machine will be in a dilemma or in a problematic state to choose which of the label. So it is always better to have a k value to be in an odd number. So then I have a sure winner and we can easily assign a label to the new data point. So that k should be an odd value is a requirement in your k nearest neighbor algorithm. So now let us try to see this hyperparameter tuning. So how to find the best parameters for our classifier. So in order to do that, we divide our data set into 3 categories. So we already know from my earlier video. So we have a data set. So data set is divided into two categories. One is training data, another one is test data. So training data is used for teaching a machine, whereas test data is for evaluating the machine. So now in order to have this hyperparameter tuning, what we do is we divide further this training data into two categories. One is training data, another one is for validation data. So now, due to which I have three sets of data: training, validation and test data. So this training data will be used for training the machine by setting certain parameter. And then after training the data, I use the validation data to evaluate the machine. Note down its performance metrics. Next, again same way, by selecting another parameter, you try to train the data, and again note down the performance metrics on the validation data. So like that we try to list the data. After listing the performance metrics for different parameters, we try to choose the parameter which gave the highest performance metrics. Then use that parameters to retrain the data. Once retraining is done, we try to expose the test data to evaluate the machine. So let us see this procedure in detail. So we use a 3-split key scheme. So first, train our classifier on the training data using various values of k. So for example, I will use k equal to 1. Do the training process and then validate the model using the validation data. Note down the performance metrics. Same way, I change the value of k to be 3. Do the same procedure and get the performance metrics. K equal to 5. Do training and validation. Note down the performance metrics. So let us consider we have taken 3 cases. So now I will look at this performance metrics. Which performance metrics gives me a higher value? So for example, if k equal to 3 has given me higher performance metrics, then I should select this k equal to 3 and again redo the training process. Redo the training process. Once my training is complete, I expose the trained model to the test data. So this process is done to identify which parameter gives me the best result. Once I have identified that parameter, then I can use that parameter for retraining the model, so that our test data, when we expose it to the model, it will give the best result. So that is how this hyperparameter tuning is carried out in your k nearest neighbor classifier. So here in this video tutorial, I have talked about the fundamentals of k nearest neighbor algorithm and how to tune the parameters in a k nearest neighbor algorithm. Thanks for watching. Please subscribe for more technical learning. Thank you.